Okay, welcome back. For our next session, we have Amanda Rousseau, .NET Hijacking to defend PowerShell. So here's Amanda.
Can you guys hear me? Sorry, I talk really low. So my name is Amanda Rousseau, and I'm actually a malware unicorn on Twitter. But I'm a senior malware researcher at Endgame, and I focus on both Windows and OS X and sometimes Linux malware. I really love malware, and I have this little sticker up front if you want. It says, "Give me your malware." So I'm always asking people to give me their malware. But so the goals of today is, we all know PowerShell's in a lot of attacks. So we want to run PowerShell in a normal environment because IT guys use the same thing to do their setups, right? We want to analyze deobfuscated commands. I'll explain that later. We want to remain stealthy in the environment and avoid any bypasses. I'll talk about that. And allow a runtime analysis for either blocking or just regular detection. And we want to make sure we can support PowerShell version 2 through 5. So there's this joke I have with like the PowerShell guys that, you know, it's PowerShell. It's kind of a stupid joke, but things I can do with Photoshop. All right, so I'm going to go over the attack history first, just a little overview. Try to go over .NET. Bear with me. I know if you already know .NET, I'm just going to run through it really quickly and highlight some of the points that are important. And then I'm going to go over PowerShell, specifically bypasses and all that stuff. And then I'm going to talk about how I do C# DLL injection in some of the solutions that I'm going to talk about today. So for my solutions, I have 4 different types. I went over IL binary modification, CLR profiling, the JIT compiler hooking, and C-based method hooking. So I'll talk about those as much as I can in 30 minutes. So this is the timeline that I've put together of PowerShell frameworks and PowerShell malware that has been used in the last couple of years, since 2012. So you can see PowerSploit, everybody knows Hijacking, the offensive framework. PowerLeaks, which was one of the first used in using to pivot for the payload being fileless and all that. And then if you keep going down, we remember PowerDuke. I think it's the same guys who did the DNC hack. So normally PowerShell in actual campaigns is used to transition from the exploitation part of the stage of the attack to the second stage, which is the actual payload. So it either becomes a payload or it executes the payload. So some of these examples are PowerLeaks, PowerSniff, PowerDuke, and some Hunter exploit kit variations. Oh, and also another thing. I'm known for making these terrible, bad malware pickup lines, but it kind of has you learn a little bit about what I'm talking about. So it says, "Hey girl, do you like PowerShell?" And imagine, because it's Mr. Robot themed for B-Sides, right? Because I'd like to stay persistent in your memory. So if you remember, I said earlier, there's a lot of fileless malware or fileless attacks based on PowerShell. So just so that you guys can wake up a little bit. So it's also known for obfuscation for some of these attacks. If you can see, like the invoke obfuscation was made by an offensive security researcher. You can see the invoke command is actually in a whole bunch of different section strings. Even the coin vault, when you decompile the binary, when you get the C# code, you can see that they're using different types of characters to change the actual names of the functions. And on top of that, there's these code protection applications. If you're familiar with ConfuserX or Confuser, which was actually used in Coin Vault. And then there's .NET Reactor, which is actually the commercial version where it comes with string encryption, anti-decompilation, control flow obfuscation, and anti-tampering. And you pay for that. I think it's free now, but it's kind of discerning when you're trying to look at the malware. All right, and then we have well-known offensive frameworks. I'm sure you're familiar with PowerSploit, Hijacking, PS Attack, and PowerShell Empire. I think PowerSploit was absorbed by PowerShell Empire a little bit. So the same attacks are in there. So what these are used for, because PowerShell is really good at automating tasks, It's used for post-exploitation. So it can do all these fun little things like analysis evasion, privilege escalation by administering mimikatz, lateral movement, exfiltration. And they can reflectively load a PE in memory. So you can have a PE in bytes and like within the exploit, and you can load that payload into memory without even touching the file system. All right, and of course they try to improve themselves over time. So I have this lovely view of what .NET looks like. So I'm going to go over the CLR, the JIT, strong named assemblies, engine assemblies, decompiling .NET binaries, and finally the intermediate language. So I don't know if you want to see that again. All right. So the common language runtime handler, this is basically what makes .NET cool, is that it remains agnostic across different architectures because it uses this IL code that it manages to do the groundwork. And as I explained before in the diagram here, when C code gets compiled, it turns into IL code, which we'll talk about. And this all gets handled where the JIT turns that into native machine code, which is CPU instructions. So you can see, this is actually from PowerShell itself. When you decompile it, you can look at the script block create. This is what the C# code looks like, and this is what the equivalent IL code looks like. All right, so what does the just-in-time compiler do? So when it actually gets a function, which we call a method in C#, it will go through, it'll look up the method in the data table, create a memory block, convert that IL code into normal CPU instructions, save it in that memory block, update where that memory block is in the method table, and execute that code and return back to the compiler. So when I say looking up that information, I mean these different tables. So in the beginning of an assembly file, a DLL, or at exe, it'll have this information. So the only ones we care about is module def and member ref. And so keep in mind that these have like the names, location, offset locations, or the tokens, as I say on the side here, of where everything is. So this is just to give you a hint. I'm guessing you guys are going to get the slides later. So what you have to do to traverse these tables is basically like a linked list. So if you can download the compiler, what is it called, PDB files, so you can get the offsets to where the functions you need to use to start traversing the linked list. So just an example. All right, so Microsoft Intermediate Language Code. So as I explained before, the code that you saw of the script block, you can see that each is actually a couple bytes long for a NOP or whatever. And say you wanted to do a jump, you can have the token, which is a little Indian byte order address or identifier, and then the jump call there. So this is kind of important when you're creating your own IL code to do the hooking itself. Like for instance, I use that jump to do the trampoline for the hook. All right, and then one of the other things is if you're trying to do sneaky code in IL, the JIT optimizes the IL instructions. So say if you want to do a NOP sled in freaking IL code, they're going to remove all the NOPs because it's trying to optimize the process. So for all you offensive folks out there. All right, and another thing is when arguments are actually pushed on the stack, it's a stack slot. So you can see here in the beginning of this function, when you disassemble it, you can see there's a max stack of 8. So this is where arguments and local variables will go. So this is kind of important when you're trying to make the prototype function for the hook. And also, if you want to get the actual location of where the code is after JITted, you can call the get function pointer. And I'll talk about that later. All right, decompiling .NET binaries. It's not as crazy as it seems. There's a lot of tools out there already that allow you to decompile. I mean, shoot, the SDK already comes with the disassembly exe, and you can just look at the code there. .peek, DNS Spy, IL Spy, some of these are all open source. I think .NET Peek, it's more of a commercialized version of it, but it's not as handy as the others. And this is an example of what .NET Peek looks like. I actually used this one to go look at the system automation DLO, which is actually PowerShell itself. So you can just rummage through there and find the functions that you actually want to look for. All right, so another thing to keep in mind is strong name assembly. So what does this mean? It means that they tried to tamper-proof these DLLs that are, globally accessed, but I'll tell you how to bypass it in a second. So what they did is with the publisher's public key and private key pair, they created this little hash called the public key token within the top of the assembly, right? And then usually these gets placed into the global assembly cache, which you can see the different locations here. So with weak assemblies, it'll just look for the file name, while globally cached assemblies will look for the actual signature. All right, so back in 2009, it was discovered that the .NET Framework 3.5 Service Pack 1, you can actually bypass the strong name like anti-tampering by just placing that into the folder location of GAC, right? And it would just look for the signature rather than actually validating that it's the right one. On top of that, you can disable with the registry keys here if you want to check for strong names across all of them. Or if you want to do it specifically for one application while you're building in like Visual Studio, you can just put that into the configuration file, which is nice if you're doing bad stuff. But all right, nggen assemblies. So what is nggen assemblies? It means that it uses this exe to convert to pre-JIT IL code into native CPU instructions. So why do they do that? They thought that JIT compiler was too slow because it has to compile the first time it runs. So it automatically creates these native images in this location, and it'll first look for this DLL before it looks for this DLL. So you can identify the native image by the NI at the end of the DLL. All right, now we're to PowerShell. Okay, so we know that we talked about .NET stuff, so that's important because we're going to look at everything underneath systemmanagement.dll and monitor that, okay? So we know that this DLL is in the global cache, as I said before. We know that PowerShell can reflectively load assemblies, so of course we want to monitor this part below. Can run unsigned scripts. Well, that means it can run locally, so we can have something locally monitoring something. And then run scripts that are interpreted by base64 strings. So by that account, we need to monitor when the string gets parsed. All right, so as I explained before, I kind of hinted on the functions that hold the strings that are parsed into the actual code. The script block is actually where the string gets parsed. But it's important to note that this script block changes from version to version. So I have this nice little reference table for you to know, what version of PowerShell goes with what version of .NET, so you know how to create your payload. All right, here's another pickup line. It's like, hey girl, do you like PowerShell? I can tell you do by the invoked expression I gave you. So invoked expression. So this is actually very popular in a lot of offensive frameworks. What it's basically doing is you can invoke commands through the run spaces library in a regular C# executable by actually using the globally cached assembly and just say using the PowerShell DLL system management automation. And then you can run that exe just to run scripts like from a normal input. So how the hell are we going to monitor PowerShell if PowerShell.exe doesn't need to be needed to run the malicious PowerShell scripts? So that's what I mean by invoke expression and invoke command. You can do this without PowerShell.exe. So another crazy thing it can do is invoke it can get Windows API. So you can see here it's calling the system DLL, and it's getting the get module handle and get module or get proc address, so it can get the function right to virtual address memory. So this is actually taken from the PowerSploit framework invoke shellcode. So what it's basically doing is it's getting that right to virtual memory address, so it can write its shellcode to the process's memory after it gets the handle, of course. So that brings me to the anti-malware interface by Microsoft. Oh, you can see it already did its thing there. This was brought into PowerShell 5 Windows 10 in 2015. And so the whole point was to allow Windows Defender and third-party applications like AVG to scan the script block when the codes get invoked. What it does is it performs a security check, goes to the AMSI DLL scan interface. Through COM interface and RPC, it sends it to Windows Defender to get scanned. So what this provides is memory and stream scanning. It looks at the code before it gets compiled, right? So this is already deobfuscated. And then when you want to detect C#, like the C# usage of PowerShell, you can, because it's already built into the system management automation DLL. All right, another cool feature. So if you use that decompiler I told you about, you can go decompile the system management DLL, and Microsoft already has these suspicious methods in the code itself. So, okay, so they're using these as the suspicious methods, right? So how do I look at those too without using AMSI? Why? Because the AMSI can be bypassed. It was already shown, like in Nishang, there's an AMSI bypass that if you use the string obfuscation for specific variable names, you can bypass Windows Defender. All right, and you can also disable AMSI two different ways. You can use the PowerShell command MP preference, here for reference. And then you can do DLL load hijacking, was found by another security researcher. All you do is you create, if you know the concept of DLL load hijacking, it'll look for the assembly in the same folder that is being executed. So in this case, he was loading AMSI DLL, but it's a dummy one. You can see down here, I don't know if you can see in the back there, it's just got a fake message box saying that it was loaded. So when it fails over, it just unloads the AMSI DLL altogether. All right, and this one's tricky. This one was from Matt Graber. So what it is you can using reflection, you can go and change the values of things that have already been triggered. So in this case, when AMSI loads, and this is actual code from AMSI, I pulled it out for you guys. So when it initializes, it checks to see if it failed right here. So what he's doing is he's changing that value to true so that it won't even load. So you can do that in real time and unload AMSI. So that brings me to all the different methods. Make sure I'm on time. So I'm going to talk about how I did the C# injection, just a high-level overview. I'm planning to release a paper, a research paper with this, so it'll have more details, but I just want to go over it so you guys know. And then .NET rootkits with the binary modification, CLR profiling, the JIT compiler hooking, and C-based method hooking. So now that you know a little bit about .NET, I'm sorry, but you do now. Sorry, I've only been working with .NET since November. So this is like a whirlwind of crazy shit for me. So I think I went too far ahead there. So what is the C# DLL injection? Keep in mind that C# does not have a DLL main. So when you try to inject your DLL, you're going to have to make that DLL main. So by using a C wrapper DLL, remember it's unmanaged code, so you'll have to manage the versions, which I hinted before. And from there, you stick that sucker as a byte array in your resources, and you can load that when you need to. So by using a DLL injector or a filter driver, which is common for AV, you can inject that wrapped DLL into the target host, and then figure out what version of CLR that they're using. And so here's kind of like the code that I use to actually attach to the process's CLR. Once I figure out the version, I can use my co-create instance and access the host process's CLR. And then I can grab the app domain, because in order for my C# DLL to actually run, it has to be in the app domain of this host process. So that's basically what this section of code is. It's grabbing the app domain, and once I get the app domain, I can add myself to that app domain. All right, so that brings me to a different topic, .NET Rootkit binary modification. So this was actually 2009 Black Hat talk. Okay, Black Hat talk from Matula. So what he did was he disassembled the IL, insert their own function into the IL, writing the code itself, reassemble it, and place it overwriting the original DLL. So if we were to do the same thing, I would overwrite the system management DLL with my hooked code that would load my own special monitoring DLL. So as I explained before, so there's a couple things problem with this. You need to make sure that it doesn't validate the signature. And also the hash changes. So if you have any type of whitelisting or cert verification and you have your good monitoring DLL there, it's not going to pass. So you're going to have to make some type of nice environment for it to do that without having the attacker know. But you're also putting something in the environment, so that's another thing. You change that DLL, that means the attacker can get that DLL and reverse it if they have it. All right, so how does binary modification work? So there's also a lot of open source tools out there to avoid this human error, because you don't want to mess up how your stuff gets on the stack, how your hook works, and what you start loading into memory and all that. So these .NET exploit, .NET hook library, mono-CISO, which is more the common one that I've seen, and I've actually used it myself. You can statically or dynamically modify the IL code, recompile everything, and push it to the target process. So this is all the crap that you'll have to go through in order to figure out how to get your assembly into the same working memory of the host process. All right, so luckily there's this cool API that Microsoft gave .NET. It's called the CLR Performance Monitoring API. It's basically a way where you can register your own CLR profiler to access when a module is loaded and unloaded. So it gives you this function that you can add code in there to access, say if system automation DLL got loaded, you can say, okay, give me the handle to that DLL so I can inject my app domain, or inject into the app domain of that target process when it loaded. So it's kind of a weird way, because you have to register your DLL normally, like in the assembly. So you already have one artifact in the assembly. And you have to turn on the environment with an environment variable that says CLR profiler equals 1. So if the attacker knew that it was 1, then that means I'm being monitored somehow. All right, and then you do the same thing where you use your C# DLL when you're wrapped DLL to do the hooking. And when I mean hooking, what I mean setting the hook. So when you control how the function gets created, you can dynamically create the trampoline. So the original entry point of the function, you have your trampoline method. So this is exactly what I'm talking about. You rewrite that function's code, and you have your hooked code here where you can do your monitoring. And then from there, it points back to the original target and returns with the right information. Or you can kill it if not, depending on what type of logic you do. All right, so the next solution is JIT compiler hooking. So what this actually is I am replacing functions for my own functions in the JIT compiler itself. So like I said before, you have to use your C# DLL injection again. And then once you're in, you figure out what version it is. You replace the JIT compiler, the compile method, and then you start doing your hooking code while it's being JITted. So what does that look like? Okay, so this is actually when how you would use like EasyHook to hook the actual compile method. And from there, you can recompile IL code on the fly and push it in memory as it's happening. So you can do all that as soon as it starts jitting. Jitting, not shitting. So this is kind of like what the output looks like. This is when I'm actually testing PowerSploit's sharp pick. You can see it's using the run spaces here. So this is its first when it jits. So you can monitor like when it's going through all these different methods as it's happening. So this is when you would actually, okay, 5 minutes, when you can actually start following some of these methods and insert your hooks. All right, C-based method hooking, the final one. So instead of hooking on the JIT level, we want to hook when it gets down to the native CPU instructions. So you're actually creating your normal, assembly instructions to do the trampoline. So this was actually from Topher's DEF CON talk. I think he did the Black Hat talk too. He actually created an offensive tool that would just overwrite code blocks in memory because he had the ability to, because memory locations were RWX. So in this case, we're doing something good and not bad, unless you want to do it bad. Or you want to overwrite that with good assembly instructions to do the hook, rather than overwriting it with shellcode, which you could, but I don't recommend it because you'll probably crash the program. All right. So how to do that? So you use the pointer reflection. As I explained before, once you pre-compile the method using the prepare method, you call this function get function pointer, and you can get the actual pointer as it exists in virtual memory. And so, but the problem is, like I explained before, you don't want to crash it. So you want to make sure you get you need to understand how to convert IL code into assembly code, and then figure out the arguments, and then figure out how to do the prototype. So you have to do multiple layers deep, like .NET Inception, to make sure you get everything correct. All right, so the results. So, wow, you really can't see the colors here. So what I did was I laid out like what are the points that I wanted to get across. I can do runtime analysis. I can run on PowerShell 2 and above. I could do stealth versus AMSI. I'm doing something similar, but I'm making sure by using my injector properly or my filter driver properly, I can inject without being known I'm there, because I'm working on a lower level. Any system artifacts. I found that the CLR profiling in the IL binary had some artifacts, so I was like, I don't know if I want to use it or not. Does it have to have Engine installed? So another thing is, if you have an Engine native image, it'll bypass the JIT compilation stage. So all your efforts you're doing in the JIT location it's not going to work. So you're going to have to uninstall it. So that makes a big difference when you're deploying into a customer environment. All right, and then at the same time requires signature validation. Like I explained before, if you're trying to bypass a signature, you need to make sure that you can in the environment. And also difficulty. I labeled everything in difficulty on this chart. So what I came up with is like this would be my first choice in doing the solution. The machine code manipulation, the JIT hooking, which was really fun. I think this one was my favorite, but it would be less sneaky if I couldn't do Engine. And then IL binary modification, because this one's the best and safest one you could do, but it's also difficult if you don't do it safely. Depending on what open source tool you use, I would probably not use mono CSOL. I would probably just do it myself, but that's pretty much it. So takeaways. Like I explained before, you should intercept the actual PowerShell method rather than the script. And then you want to stay stealthy. Do it right. Don't crash PowerShell. Please don't crash PowerShell. And then welcome to my .NET hell. All right, any questions?
What's PowerShell?
Shit, I don't know. You know, I just spent a couple months on it. Anyone else? Sure.
Is there any additional vectors that you wish you had more time to look at?
Yeah. You know, I explored regular AIT hooking as well, and I kind of want to go back to that. But I think I'd probably focus more on a lower level, even lower than that, like the native images. But I only had a couple months, so yeah. My boss was like, "Go research PowerShell." Okay. Okay, I'll start with .NET. Yep.
Just looking at your table, using NGen, PSW, uninstall, just kind of cross all the things there. Is that something that we should detect as malicious, or is it occurring in normal usage there?
Yeah, so NGen was mainly used for improving performance. So if you were to pre-JIT the assembly, then that means it doesn't have to go through the JIT compiler, which means it'll run faster. But the only downside to that is you don't have the optimization per operating system.
So if you take it out, you can break other things?
No, it'll just look for the next best thing. Like it has the DLO load order, right? Yeah. Anything else? Okay. Awesome.
Amanda Rousseau, thank you very much. And from our sponsor, Fitbit, those of you who've been around recognize this, a Fitbit for you. Awesome. So, yeah. Wow. How's that fit? Okay. Don't forget happy hour at 5:20 with Salesforce.